These are the day 2 notes for our confidence intervals unit. Today we're going to talk about, again, how to calculate a one sample z-interval, which we learned how to do in our notes 1 activity. We're going to talk about what a confidence interval actually means, so we'll go about interpreting a confidence interval. And then on the back side of our worksheet today, we're going to take a look at the steps that you will need to write down if you're constructing a confidence interval on an AP exam. So first of all, a little review from what we did yesterday. Let's look at problem 1 here. It says, let's construct a one sample z-interval to predict the mean year that the pennies in the box were minted. We're going to say in a sample of 5 pennies, let's say the mean year on the pennies was 1989. Assume the standard deviation of the population is 10.8 years. Let's construct a 95% confidence interval for the mean year. So yesterday we talked about our formula for a confidence interval. X bar plus or minus z star times sigma over the square root of n. And let's go through the example and start harvesting out what these different variables mean. You might recall that X bar stands for the sample mean. In the problem it says, let's say the mean year on the pennies was 1989 in a sample of 5 pennies. So the sample mean is 1989. That's what we'll substitute for X bar. And then we have our plus or minus. So when we look at our table B from the other day, we can find z star by going to this bottom row that has either a z star or a little infinity symbol next to it. Scroll all across this bottom row and then locate 95% confidence right below it, and the z star value should correspond with this number. This is a pretty common one that we use a lot in stats. 1.960 is your z star. Now we're going to multiply this by sigma over the square root of n. Sigma is the standard deviation of the population. It says assume the standard deviation of the population is 10.8 years. That will be our numerator. And it says in the problem the sample size is 5. That's going to be your n value. When you type this in your calculator, I'm going to start with typing in the equation with a minus sign first, and we get 1979.5. And then if you hit second enter on your calculator and replace the minus sign with a plus sign, you'll get the other number on the other end of our interval. And that number is 1998.5. So what does this answer mean? Let's talk about interpreting this answer next. Based on your answer that we just got, you can say a few things. So we're going to fill in some blanks here. You can say, we are. Now our confidence level in this problem is 95%. So we're going to use that percentage in our interpretation. We're going to say we are 95% confident that the mean, in the problem it says mean year. So we're looking for the mean year. It says this twice, so that's what we're looking for. The mean year is between the two numbers we got, 1979.5 and 1998.5. So that's one interpretation, is we're 95% confident that the mean year of all the pennies in the container is somewhere between these numbers. You could also say there is a 95% chance that the two numbers we got, 1979.5 and 1998.5, is one of the samples where the true population mean is within the confidence interval. What does this mean? It means that if you got these numbers, now this is based on our sample. Somebody else could have taken a sample and gotten different values. But there's a 95% chance that the interval we got between 1979.5 and 1998.5 is a sample where the true population mean is within the confidence interval. So there's a 95% chance that the actual mean year of these coins is between these values. Now we should have a graph in class from yesterday where everybody in class calculated a 95% confidence interval for the mean year minted for all the pennies in the box. It might resemble the graph that you see over here on the right side. So one other interpretation is we could say this. If we were to choose random samples of size, now we use size 5, so I'm going to replace the size with 5, over and over again, 95% of these 95% confidence intervals should contain the true population mean. In other words, all of these samples that you did, all of these horizontal lines that show different confidence intervals for different sets of pennies people draw, 95% of these confidence intervals, and these are 95% confidence intervals, should contain the true population mean. Whatever you get for this number, you're going to have for this number. So 95% of these 95% confidence intervals should contain the true population mean. And we're going to say that population mean is that line that's going straight up and down there. If that's the actual mean year, probably around 1988, the 95% of these horizontal lines should basically pass through 1988. So the graph at the right simulates our graph of our confidence intervals that you made in class, with 50 confidence intervals graphed. About how many of these confidence intervals should contain the actual population mean displayed on the graph by the vertical line? So what we would expect is that if these are 95% confidence intervals, 95% of them should contain the mean. Whatever the mean is, 95% of these lines, or 95% of these intervals, like this one, you should be able to get that mean, 1988, in between these. So there should be a lot of people that have something like 1979 to 1998, for example. It would be unusual for somebody to get something like 1960 to 1980, or 2000 to 2020. 1988 should appear somewhere in between these two numbers in basically 95% of our intervals. So 95% of 50. So we're just going to take 95% of 50. And when you calculate this on your calculator, you get something around 47.5. So if you want to answer about 47.5 of these 50, or if you want to say something between 47 to 48, I think that would be acceptable. When you are talking about confidence intervals, there is one thing that you cannot say, however, and you cannot say that 95% of the coins were minted between the two numbers we got, 1979.5 and 1998.5. A confidence interval is used to predict a parameter, like a mean. It does not predict individual results. So these two numbers are describing where the mean is between. It's not saying that, for example, 95% of the coins are between these 2 years. In fact, you might not have any coins between these years. Maybe you have a bunch of coins from the 1970s and a bunch of coins from the 2000s. They come together and average about 1988. So what we have to say is that the mean is between these numbers, not like 95% of the coins are.